Grade 12, welcome yet again to another video. Today I'll be looking at packaging, which deals with the most optimal way of putting items into a container and therefore reducing costs. So if you're planning to go to a trip, one would want to put as many items in a small space so that they don't have to pack a lot of bags. So I'll be doing, or rather I'll be going through this topic with a paper from 2023 preliminary exam, Gauteng province. Right, so in this question, this is what the grade 12 were actually asked. Sipho bought canned fruit and he must pack the cans in a plastic container. The dimensions of a can and a container are as follows. The diameter is 6 centimeters, the height is 12 centimeters. And then that of the container, we have the length being 126 centimeters, the height 72 centimeters, the width 53 centimeters. And then I also showed here to say whenever we're trying to pack, we want to check how many of these cans can fit into this plastic container. So we'll do it going along the length of the container, along the width of the container, and along the height of the container. Right, so the question is as follows for 7 marks. Tumelo advised Sipho to pack the cans upright so that he can pack 1,134 cans in the container. So we need to verify whether his claim is correct or not. Another important thing to note, grade 12s, is that he said he needs to pack these cans upright. So it means they need to face upward or upright, like I've just indicated here. So it means we cannot pack the cans in this direction because obviously whatever it is that they are containing, it might spill out. Right, so without any waste of time, let's quickly write down our information. We have for the can the following. Right, the can has a diameter of 6 centimeters and a height of 12 centimeters. Right, and then if we are looking at our container has the following dimensions. The length is 126 centimeters. The height is 72 centimeters. And then lastly, the width is 53 centimeters. Right, before I start, we are only going to consider a practical way of packing in mathematical literacy because it gives us the most accurate answer. And then I'll do the mathematical approach later to show the difference and as to why which one works better than the other. Right, so let me just draw our container. This is our container. We have something of this nature in 3D. Right, so from this container, obviously, this is our length, this is our width, and this is our height. So what we are actually trying to do here, grade 12s, we're trying to see how many of these containers can we fit in this direction. And if you can check already, you can see that there are spaces in between. Right, so we just want to see along this direction how many of these containers can we fit. And then looking at that, we know that the line that cuts any cylindrical container into half is called the diameter. So we have the diameter here. And then obviously we need to do the same. Looking at this container from the side, this is what we have. And then again, we want to see how many of these now can we fit in this direction. So how many can we fit in this direction and how many can we fit in this direction? Similarly, if we are able to pack them on top of each other, how many can we stack or how many can we pack on top of each other? So now looking at this one, this In this direction, we have the length across the diameter, or divide by the diameter. Then in this direction, we have the width still by the diameter. Then if we're looking at this direction, we actually have the height of the container by the height of the smaller nyana can. Right, so let's just do calculations. Number one, we are going to look at the length. So lengthwise, we want to find the number that can fit. So lengthwise, it means we take the length of the big container, we divide it by, what's the length of the small container? In this case, it is the diameter of the can. Then we have the following from the information. The length of the container is 126, the diameter is 6 centimeters. So we'll have 126 centimeters divided by 6 centimeters. Right, a quick calculation. We'll have 126 divided by 6. We get exactly 21. Right, what does this 21 mean? The centimeters cancel. We are looking for a number, so the number is exactly 21 cans. So it means we can fit 21 cans going in this direction, ladies and gentlemen. Right, in this direction, we now know that we can pack 21 cans. Right, then let's look at the width of this container. How many of these cans can we fit? Right, so we'll go width-wise. So width-wise, again, we're looking for the number. The number will be the width of the container divided by still the diameter of the can, because the can is exactly in the 2 dimensions. Right, then the width of the container, we have the width of the container being 53 centimeters. And then the diameter of the container is still 6 centimeters. Right, the ratio of these two will have our 53 divided by 6. Then, ladies and gentlemen, this step right here is very, very crucial. We see that we have 8.8333 recurring. Right, so this point right here is very, 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 very crucial. Now, whenever we try to pack something, we're trying to pack it as a whole. So we don't consider half a television, half a car, a quarter of a car, a quarter of a cell phone, but we consider it as a whole. Right, so it means these decimals we don't consider them because it's actually a part of this container. So right from this point, we introduce the concept of rounding down. This is very important. Any question that you deal with under packaging, because we're packaging full items, we always going to round down. No matter how close the number is to the nearest number or whole number, you always round down. Like this one, we know that this would be a 9. However, this is approximately 8 cans because we are rounding down. So it means, ladies and gentlemen, in this direction, we can fit 8 cans. And then lastly, we've considered the length of the container, we've considered the width of the container. Let's consider the last dimension, which is the height of the container. So let's look at height-wise. So height-wise, again, the number is going to be the height of the container divided by the height now of the can. And then in this case, the height of the container is given to us as 72 centimeters. And then divide by the height of the can, which is 12 centimeters. Then you will have your 72 divided by 12, which gives you exactly 6. So this gives us exactly 6 cans. So it means on top of each other, we can stack, right, let me have this drawing again. On top of each other, we can stack 6 containers on top of each other. Right, therefore now, how do we then find the total that we can actually fit into this box? The total that we can fit into this box, so we now know that we can fit along the length, we can fit 21, along the width we can fit 8, along the height we can fit 6. So how many can we actually fit inside or into this container? The answer is easy. To find your total, you just take the totals that you can fit in each dimension and you multiply them. So you'll have your 21 along the length times the 8 along the width times the 6 along the height. So let's just check quickly. If we take our 21 multiply by 8 multiply by 6, what do we get? We get exactly 1008. Right, this 1008. Looking at our question said Tumelo advised Sipho to pack the cans upright so that he can pack 1134 cans in the container. So if we pack them like this, we can see that we get exactly 1008, which is invalid or less than what we have right there. Therefore, his claim in this case is invalid, or Tumelo is not correct. Right, so we have answered the question, and I did say earlier I want to also consider the mathematical approach. So looking at the mathematical approach, it means now we need to use the volume, the formula. So if we are using the formula, why does one work and why does the other one not work? So let's look at the volume of the can, because the volume of the can takes the shape of a cylinder. So the volume is going to be pi r squared. So looking at pi r squared multiplied by the height. So we know that we are given the diameter, which was 6 centimeters. Therefore, it means the radius is going to be the diameter divided by 2, which is 6 centimeters divided by 2, giving us exactly 3 centimeters. Right, quick substitution will have, we know that our pi is 3,142 times radius, we have r times this h. Why do I multiply r twice? Is because we have r squared. Therefore, this gives us 3,142 times what is my radius is 3 centimeters times what is my radius again, 3 centimeters times what's the height of the can, it's 12 centimeters. Right, a quick calculation of this one would give me 3,142 times 3 times 3 times 12, which gives me 339.336 cubic centimeters. Right, so this is the volume of each can. Let's look at the volume of the container now. Right, our container takes the shape of a rectangular prism. So for a rectangular prism, its volume is going to be length times width times height. Therefore, we'll have our length being 126 centimeters multiplied by 53 centimeters multiplied by 72 centimeters. Right, this product will be 126 times 53 times 72, which gives us 480,816 cubic centimeters. Therefore, it means the number of cans that we can pack is going to be the volume of the container divided by the volume of one can. Then the volume of the container, which we just calculated, is 816 cubic centimeters divided by the volume of one can, which we calculated, ladies and gentlemen, to be 336 cubic centimeters. Again, cubic centimeters with that, they cancel because the units are exactly the same. So doing this one, it would say these are the number of containers or cans that we can fit in, 1416.93, which would be approximately 1416 cans. Right, so looking at this one and comparing it with the one that we have right here, the practical method takes into account that in between these containers, grade 12s, in between these spaces, in between these containers, there are gaps, grade 12s. So if you just pack a container, a cylindrical container, next to another one, a cylindrical container, you would realize that these containers do not touch completely. There is this gap right here. There's also this gap right here. And then because of those gaps, the practical method takes into account that there are those gaps, which means we eliminate those gaps whenever we calculate our cans that we can fit. However, if you're using the volume, the formula does not take into account that there are spaces in between these containers. It is going to treat this problem as if all the space inside this box is occupied fully without a gap. So how is this applicable? This is only applicable if maybe we are dealing with liquid. If you were to put in liquid into this container, then it means all the corners and all the spaces inside here would be occupied. Therefore, the volume using the formula will definitely work. And then also, if maybe you were putting in sand, anything that can cover all the space in here, then the volume or the mathematical method would work. We are not saying it's incorrect. We are just saying that it's just not applicable for this one. It is a bit misleading. So if you go the formula way, it means now if you have bought items and you want to transport them back home, and then you use the formula, it will tell you that in this car I can fit in 1,416 cans, only to find out that when you get to the shop, you've bought your 1,416 cans and your car can only take 1,008. Why? Because you did not take into account those spaces in between. So yeah, grade 12s, this is how a question on packaging should actually be approached. So the concept here, whenever you get a decimal number or decimal fraction, always round down. We are not rounding up. You can only round up when you are building with building materials. If you are buying a tiles, and you find that the area that you need to tile requires maybe 4.53 tiles, and then you can always buy 5 tiles, because you cannot buy 0.53 of a tile, but you need to buy 5 tiles, and then obviously you will have something that is left over. So yeah, that is not the case with packaging. With packaging, we always round down. Right, grade 12s, if you have any questions, please leave a comment, then I'll see you in on another one. Goodbye. Cheers.